Hello, and welcome to Alchemy of Thoughts. And I'm your host, Dr. Manohar Rao, where we try to simplify science for laymen's through storytelling. Today, I want to talk about a compound, ammonium nitrate, a substance designed to nurture crops but often found at the center of forensic investigations and breaking news alerts. For decades, ammonium nitrate has been central to agriculture and some regulated industrial blasting. But its chemistry, as a potent oxidizer, makes it vulnerable to misuse in improvised explosive mixtures. Tragic episodes from Beirut to incidents in India echo the same pattern: poor storage, weak tracking, and easy diversion for sinister purpose. Let's begin with the basics. Ammonium nitrate is a chemical salt, an efficient nitrogen rich fertilizer. In agriculture, it's a hero. Farmers value it because it encourages rapid plant growth and boosts yields. It has supported global food production for decades. But as with many things in science, its strength is also its risk. Ammonium nitrate is a strong oxidizer. On its own, it's stable. But mix it with carbon rich fuels, diesel, kerosene, or even simple hydrocarbons, and suddenly you've created an energetic mixture capable of catastrophic explosions. To understand its present Delhi controversies, we must glance back. After World War II, ammonium nitrate became widely available as a fertilizer. It played a big role in rebuilding agriculture and ensuring food security. But its scale of use meant accidents also began to rise. Warehouse fires, industrial mishaps, and improper storage. The global wake up call came in Beirut in 2020 when 2,750 tons stored in a warehouse detonated, creating one of the most powerful non nuclear explosions in history. That incident forever changed how countries think about ammonium nitrate storage, tracking, and regulatory oversight. You might wonder, if it's so risky, why not ban it? Well, because ammonium nitrate also feeds millions of people by supporting agriculture globally. But misuse typically stems from three issues. 1. Accessibility. It's widely available in agricultural supply chains. 2. Poor storage practices. Heat, humidity, and contamination can destabilize large quantities. 3. Informal distribution networks, especially in developing regions where tracking is inconsistent. It's not the chemical molecule that's dangerous, it's the environment we put ammonium nitrate in. When an explosion occurs, forensic chemists and criminal investigators aim to answer several critical questions quickly. Was ammonium nitrate present? In what form? Where did it come from? Did it mix with fuels or additives? The analytical instrumentation workflow typically includes visual and microscopic inspection to identify unusual residues, chemical screening, rapid tests, colorimetric nitrate nitrite tests for initial identification, spectroscopic confirmation (FTIR) and Raman spectroscopy to identify nitrate and ammonium functional groups and common hydrocarbon additives, chromatographic analysis, ion chromatography (IC) for precise quantitation of nitrate, nitrite, and related anions. GCMS can help detect fuel residues or organic additives. Put together, this workflow turns scattered particles from a blast site into a scientifically validated narrative. Each analytical technique has an important role. Spectroscopy and chromatography give chemical ID and quantification, while imaging can provide physical clues that can link residues to specific signatures. These are the exact analytical tool that forensic labs will rely on to move from suspected ammonium nitrate to defensible evidence in a legal process. The value comes in the workflow, integration, and sample preparation. In order to ensure that ammonium nitrate is not used for any further sinister purpose, policymakers must prioritize tighten inventory controls. Ammonium nitrate should be monitored with the same seriousness we reserve for pharmaceuticals or industrial solvents. Strengthen storage standards, temperature control, ventilation, separation distances. These aren't optional, they are non-negotiable. Build analytical capability in regional labs. We need more labs with analytical instrumentation and trained personnel who can run and interpret these investigations quickly. Despite its grim appearance in headlines, I want to close with a clear, unbiased message. Ammonium nitrate is one of the most economically important fertilizers on the planet. Without it, agricultural productivity would suffer dramatically. It is our responsibility to ensure it's stored safely, tracked diligently, and used responsibly. Thank you for joining me. I am Dr. Rao, your host for this episode, as we explored all about ammonium nitrate that made news and headlines for the last few weeks. And until next time, stay inquisitive, stay analytical, and remember, molecules may be small, but their impact can be enormous.